Hey, welcome back. I hope you're all well. Thanks for joining the channel. Good to see you all again. So I said I was going to save the best for last, and here it is. This is a Pioneer SX-D7000 receiver, fully digital receiver. It's one of the first digital receivers I think Pioneer put out. It's really groundbreaking, and a lot of the technology that's in this thing is pretty incredible. But this is how it arrived at my place. The previous owner dropped it off at my place for my client, because my client just figured, okay, send it to Trevor and have him service it before he even sees it. So here it is. And yeah, this was part of the package deal that he purchased, where it had the turntable, the PL-8, and the cassette deck, the CT-8R. You saw in the previous videos. So this is the follow-up and the final piece of the puzzle, the receiver itself. This is how I got it. I haven't even opened it up and looked at it yet, so I thought we could do this together. So let me reposition the camera here a bit and have a look inside. This thing is big, by the way. It is massive. It says on the side of the box weighs what is this? 22.4 kilos. 49 pounds, so that's, you know, with the packaging and everything, and then a few pounds less without the box. But let's see what we got here. How do we open this? Getting a lot of strobing from my LED lights. Man, this thing is big. How many layers of cardboard do we got here? Okay, so there it is. Wow, it's big. What is this thing, about 20 inches long or wide? Okay, let me get it out of this box and we'll get it on the bench and have a good look at it. All right, so wow, look at this thing. This thing's got some presence, man. If you put this in a room, you know you're in the presence of something great. This thing is massive. I don't know if my shows you this, but yeah, I called it pretty good. It's 20.5 inches wide. This thing's 17 inches deep, and for height, what do we have here? Just about, well, 7 inches. So it's a lot of receiver here, a lot of power. Yeah, it's got a big, massive, heavy power cord, and 2 digital displays. I think one is a power meter and one is your FM tuner. A lot of stuff going on here. So let's have a good look at this. Okay, I gotta move my camera back because I can't fit it all in the frame here. Power switch. It's got a standby on. Standby tells me that maybe this runs from a remote. I don't know. I didn't see a remote in the box, so I don't know. Okay, bass and treble. You've got sliders, and we have 2 switches for turnover. One's for the bass, and we can switch between 200 hertz and 400 hertz. That's where the hinge is going to take place. And then for the treble side, we have 2.5 kilohertz or 5 kilohertz. So that's a nice feature. I know some of the Harman Kardons have this, and you can tailor your bass and treble controls to your liking. 3 sets of outputs for speakers. Okay, tone defeat button, I'm assuming. Low filter for turntable rumble. Mono mode. And then we have here towards the center, we have Here towards the center we have a big massive volume knob with coaxial balance control, a loudness button, minus 20 dB muting, switch for moving coil or moving magnet cartridge, and a button to dim the displays. 2 tape monitor loops and an adapter loop. This is probably like a 3rd tape monitor loop that you can use for equalizer, noise compression, noise suppression, stuff like that. Tape duplicating from 1 to 2 and 2 to 1 or off. And then we have our function selectors, these push buttons. I'm sure they're illuminated from behind. Here on the tuner we have a great big display. I can see digital display here and signal strength. Presets. We've got 6 presets, up and down tuning, memory button, 25 microsecond de-emphasis, sorry, auto manual tuning, so that's like your scan, and AM FM mute off. So I guess it has interstation muting, and if you want to turn that off you can. So yeah, it's nicely featured, very nicely featured and laid out, and yeah, it'd be a treat to use this. Let's turn it around, look at the back. Okay, hidden back here in this corner we have a switch. It says AM channel step, 9 kilohertz or 10 kilohertz. So that selects the tuner for how it advances the frequency selection. It's got an AM bar antenna, which is not broken, which is nice. It even has a sliding adjustment bar here. It's good. AM stereo out, so yeah, you can hook up a AM stereo adapter, and that was a big thing back in the day, but it's kind of disappeared. I don't know if there's any AM stations still running. I think there is. 2 phono inputs, an auxiliary input, and then we have our preamp out, power amp in, which we can break the connection between them by removing the links. AM, FM antenna inputs, 1 tape loop, 2 tape loops, and an adapter loop, and 3 sets of speakers, 3 courtesy outlets. I was told by the previous owner that this works, aside from the usual scratchy pots and dirty switches and stuff like that. That's going to be pretty much standard affair for any piece of equipment of this age. So let's plug it in and try it out. Let's see, I got my power meter here. Now, if you can see that, let's turn it on. And we have a display on the power meter. We're drawing almost 40 watts. Let's try, oh there we go, FM. We have a display that's not, oh that's signal. Let's see here, what can we do with this? AM, auxiliary, we've got some burned out bulbs, power consumption goes up on AM, goes down on phono. FM, power consumption goes up again. Okay, there we go, 108. You said 000 before. I'm wondering if this thing has a backup battery in it. Everything seems to be working, except for a few burned out bulbs. Are we getting any? I did hook up speakers, so let's turn on speakers A. And let's try turning off the tape monitors, off. Getting anything here. Tape monitors are off. And we're on AM. We should hear something. Not hearing anything. Oh, you can only do 2 sets of speakers at once. Automatically locks you out from doing all 3. That's kind of cool. But we have no audio. Okay, let me try FM. FM muting off. I don't hear any thump or click or anything from the speakers. And I do have speakers connected, so sounds like we got a dead power amplifier. Usually when you put the speakers on and off, you can hear some kind of a click or a thump. Very faint. I hear nothing. Okay, looks like we got a little bit of work ahead of us. Let's take the top off, have a look. Wanted to do that one more time because I did hear a relay click. No, I didn't. No relay click. So maybe it's in Protect. Here's a click there. That's a power relay, I think. Okay, no relay click on the speakers. It's kind of hard filming this thing. It's so big, you want to get the camera in close, but then it just swallows up the whole frame. Here's first look inside. Looks pretty good. Has kind of a smoky smell to it. Whoa, we got dust. Yeah, we got a lot of dust. So this is a lot of years sitting out in the open collecting dust. Wow, this is a beast. Look at the size of this thing. The power transformer here looks like a toroid. Massive power capacitors. Filter caps. These are, how big are these? 15,000? 15,000 at 71 volts. I have a little hard time finding those again. Power amplifier board. Here's a relay that wasn't clicking on. This is all tuner, it looks like. And this looks like it's, well, this is our input board here with the selectors for the different inputs. And what else do we got here? This is probably preamp here. Power supply board tucked in under here. This thing is a beast. Okay, I guess the first step is I gotta haul it outside and blow some dust out of this thing. This is pretty filthy. Quite filthy. And I got a fuse block here. There's what, 1, 2, 3, 4, 5 fuses here on this fuse block. Check those first. Can't really see. Yeah, I think I see one that's burned out. I've got it unplugged here. This is awkward. They could have thought of something better for this. Yeah, there's. We got a flashlight. Yeah, we got one pop fuse. I don't know what value that is. So 10 amp fuse. So that's got to be some heavy power there. The rest of them are 1 amp fuses. 1 amp, 1 amp, 10 amp, 1 amp. And this last one I can't really read. It's a 1 amp. So that would explain why we have no power to our power amplifier, because the 10 amp fuse is gone. I hope there's no problems with these output transistors. They're probably as rare as hen's teeth to try and find output transistors. And it's got these, look at this, it has the matched pair of transistors here. This is a 2SA7, I can't read, it's all covered in dust. 2SA979, and then a 2SC2291. Same here. Alright, looks like I got my work cut out for me. So I'm going to go clean this out first, and then we'll bring it back. I can already see here on these function switches, I'm already seeing crack solders on these. And I think that's going to be the theme of the day for this thing, is crack solders and dead caps. It's definitely of that age of having a lot of dead caps in it. So, okay, I went through and I checked all 8 transistors, and they're all good. Now, I was trying to figure out what blew the fuse. So, transistors all good, but I made another dumbass move. What I did is I checked these 2 power rails, one for each amplifier, and there's no shorts on these either. No shorts on the amplifier. And then I decided to have a look at this fuse. So I pulled a fuse out. It's going to roll away on me. And it's not burned out, it's a ceramic fuse. That's what I couldn't see it because it was buried in here. It looked like it was burned out, but pull it out and test it, the fuse tests fine. So as far as I can tell, everything's working here. It's just that the protection relay is not kicking on, which tells me we might have a DC offset on one of the outputs. So I'll put the fuse back. We'll power it up. We'll check the power supplies that are, make sure they're coming up, and then we'll go through and we'll check the outputs of both amplifiers to see what is happening there. Okay, I got it plugged in. I have power disconnected from both power amplifiers, and I'm going to check the voltage on these. These are connected in parallel with each other so that they're both the same. So I got my voltmeter here. Let's turn this on. Let's see what we got for power. It's the positive rail. We got 66.9, negative rail. Negative 66.9. Between the two of them, I should have 135, 134. Okay, that's normal. So the power supply is up and we're running, and it's all working. Now I'll connect up. This is my speaker output. So what I'll do is I'll connect up both power amplifiers, and then I'll check for DC offset on this. No, that won't work because I don't have the relay clicking on. Let me try it anyways. We'll see. Shut this off and allow this to bleed down. I'll get a resistor on here and we'll bleed this down before I plug it back in. Alright. Switch it back on. And 90 millivolts here. About 16 millivolts on that channel. Shouldn't be a problem. Let's try this again. For some reason this protect relay is not coming in. Alright, here's a block diagram for the power amplifier. These are the power amplifiers, and this is the protection circuit, and this is the display circuits. So typical of a high power amplifier, we got tandem outputs. We got 2 sets of transistors, for the output transistors. And then for the protection circuit, it detects two things: overload and DC offset. So on the overload, what it's doing is it's taking a signal off between the emitter resistor and the emitter, and it's comparing it to the speaker output line, power output line. And if we have if these transistors go into heavy conduction, then you get a large current flowing through these emitter resistors, and you're going to get a DC voltage between these two. You have a potential which will be sensed by this transistor, which will shut the circuit down. The other one is a DC voltage detection. So what they're monitoring here is the speaker output line, and they're monitoring that for a DC voltage, and these transistors will shut it down too. Now, I checked on the emitter resistors of both channels, and I'm not getting a DC offset voltage. I think 90 millivolts was the highest I measured, which shouldn't shut this thing down. And we obviously don't have an overload either, because I measured with my watt meter. It's only like 45 watts or so. There's no power being dissipated here. Now, could be missing a power supply voltage, B+, or it could have a faulty relay. Could be a faulty transistor. So I'm going to keep poking around here and see if I can figure out why this protection circuit is not clicking on and letting the power flow out of the amplifier. Here's a block diagram of the power supply. Interestingly enough, this thing has a soft start relay in it. That's what they're doing here with this relay. Surge current suppressor, and then it's a relay, yeah. This is the main rails for the power amplifier. There is a output here off this transformer tap. It says AC protection. I don't know what that goes to the protection circuit. So this voltage might be missing. And then there's also a bunch of voltages out here on the voltage regulator. There's another one here for protection circuit as well. And this voltage may be missing here on this pass transistor. This one says to power amplifier. So we got a positive and negative. Funny enough, we have voltages to tuners. Tuners are working. We just don't have anything to the power amplifier. So maybe this voltage here is missing in this voltage regulator here. So maybe that's where the fault lies. So let me do some more poking around. Okay, I was just thinking about how I'm going to attack this problem with this receiver that won't come out of protection. And I was just thinking about, well, printing off schematics. I wanted to check some power supply voltages here on this power supply board and make sure everything was good there. And you know, thinking about printing out schematics and stuff. So I came over here and had a look at it, and I noticed something right off the bat that stood out. And I didn't notice it the first time I had a look at this, but just the importance of doing a good visual inspection. Let me zoom the camera in here and I'll show you what I saw. So I don't know if you can see anything on this board right now, just from where you're looking. This is typically what I saw. I didn't see anything wrong. But when you zoom in, let's have a look at this. I don't know if you can see that. Let me move this capacitor out of the way. Bend this transistor down. Can you see what's wrong with that transistor now? She blowed up. Yep. And there's a little bit of a scar on that resistor. That's just a little black mark from the soot. But yeah, that's probably our cause right there. Why it won't come out of protection. Something in that transistor popped. And we're going to have to figure out what that transistor does. And because nothing's marked here on this board. There's no part numbers. So this whole main amplifier is going to have to come out anyways, because I wanted to pull it out and inspect the backside of this PCB board. But for now, that's our problem. Here's another one on the other channel, the other transistor, and it looks like a. Let me see if I can zoom in. I don't know if it's going to focus. It wants to focus on wires. This one looks like it's got 603. It's a fairly common transistor. I think I have some of those. But yeah, it's an interesting failure, and so I'm glad I spotted that. That's the importance of doing a good visual. You see stuff like that, but like that's not really noticeable, that little bit of damage there. So like I said, I'll pull this amplifier out and we'll get it on the bench and we'll see what's going on. Now that I have the board out and had a good look at it, I found more problems. We got a number of problems on this amplifier board. Several to be accurate. We have this transistor that's blown out. And I looked at this transistor too, and the top is missing from it. So this one's blown out as well. This is the sister to this one in the other channel. I don't know why these two transistors are blown up. If I look at the schematic, let me see if I can zoom in. Maybe you can follow along here. I'm trying to figure out what condition happened to blow up these two transistors. So I got one here and one here. This is Q125, Q126. These two transistors are in the protection circuit, and what they do is they monitor the voltage across these emitter resistors. There's a set of emitter resistors here, a set of emitter resistors here. There's 4 of them here for these output transistors, and there's 4 of them here for these output transistors. Now this transistor that blew, or both of them, they monitor the voltage across these emitter resistors, and they are doing a current sense. That's what they're doing. They're sensing the current through these resistors. And if there's an overload condition that happens on the amplifier, it's supposed to trigger these two transistors, and what it does is it shuts down the relay. Now, what would cause these two to blow is really a mystery to me, because the one transistor, they're actually connected together. There's a line that runs between them. Now this line here is the speaker output for one channel. I don't know if it's left or right. And this line here is the speaker output for the other channel. And it's hard to say why, if there was a peak negative voltage on this one and a peak positive voltage on this one, it might have been enough voltage to blow these transistors. These transistors are only rated at 50 volts, and I think here we have 65 volts on our rails. But that's one theory I might have. Also, this diode here in the middle, this D132, this one's blown as well. It's shorted, and this one goes back, where does this go? Goes to pin 8, and this goes back to the power supply. I think power supply at pin 8 is an input voltage. Not sure. So we got 1, 2, 3 items blown here in this. Now, another theory I have is all these output transistors have these goofy connectors, and in my eyes these are junk. And let me explain why. If you look at these transistors, these leads on these transistors have been dipped in solder, and they have a coating of lead tin solder on them, or tin lead, whatever you call it. It's very soft. I can dig my pencil into it. These leads are intended to be soldered into the circuit, and they're never intended to be used in a connector. And what we have here is a connector, and it's some kind of spring-loaded thing. I don't have much faith in these spring-loaded, but they look like they might actually be silver-plated. I'm not sure. But you can't use a connector on transistor leads. They have a solder coating, and the tin lead solder is very soft and never intended to be used as a connector surface. If you put a connector surface on it, it'll mushroom, it'll deform, it won't, it'll oxidize, and it'll never have a good connection. So I'm going to get rid of these. These are a joke. I don't know why Pioneer did this. I guess it's just to make servicing easier, but yeah, these are bad. Look at some of these are even stretched out. So I don't know if this was the cause of what blew up the two protection transistors or not. I have a feeling it is. So I'm going to replace these. I also replaced 1, 2, 3, 4, 5, 6 capacitors. These two are weak. These two are input capacitors. They're DC blocking. I put audio grade in here. I removed these electrolytics and put in film caps. I'm going to replace these two transistors and this one dead diode. That's my next thing. And then this should be all ready to go. I did check over the backside and cleaned it. Cleaned off all the rosin flux, and somebody's been in here resoldering transistors, which is good because some of these probably cracked in the past, and somebody came in here and resoldered a bunch. And I don't see any cracked ones right now, so that's good. The problem with the output relay. It has 4 sets of contacts, normally open, and if you look on the board, what they're doing is they're paralleling 2 sets of contacts for each channel. You got one for the one channel, one for the other, and they're using 2 sets of contacts. That's just to lower the contact resistance. Problem is, I checked the contact resistance on all 4 of these, and 2 of them measure out about 25 milliohms. 2 of them measure out about 15 ohms. So I got 2 sets of bad contacts on here, 2 sets of decent contacts. So what I'm going to have to do is open this up and clean those contacts. This relay is actually sealed. It's not easily opened by the user. It's glued all around, so I got to go in here with a screwdriver, crack it open, and open this up. My other possibility would be just to replace this, but this is kind of a odd 48 volt relay with 4 sets of contacts. I don't think I would find one that would fit this footprint. So I'll just crack this open and clean the contacts, and then we'll be done with that. So I'm working on this power supply board. I just pulled it out and have a look at it, and wow, look at this. You can see that I get this out of the way. Everything's zip tied together, so it doesn't give you much freedom of movement here, but I'm just cutting them as I go and get them out of the way. These power transistors, there's 5 of them on this power supply board. They all have cracked solders. Look at how they're roasted here on the board, a dark spot. And I'm seeing a lot of other cracks too on different components. I'm going to go through and ESR all these caps. This thing here, this board here is the tone board. You can't see it, it's not in the frame. But I went through and recapped 4 capacitors because they tested weak. Now I'm finding that these caps are, some of them are pretty much dried up, and they measure about half of the capacitance of what they're supposed to be. That's why I'm changing them, because they're just not doing their job like they should. Not that they have high ESR, they just have really low microfarads for their value. Like I pulled out a 220 and it measured at 140, which is unacceptable. So those are getting changed. And I'll go through this power supply board and replace anything that needs replacing, and solder up all these bad joints. Like this one here, I can move it and I can see it. No, it's this one. I can move it and I can see it moving on the other side there. So it was broken. I'm wondering if this is the cause of my failure in the protection circuit. Kind of have a doubt, but we'll see. We'll fix this up and then we'll get things powered up and we'll try it out again. So I'm finding lots of bad stuff in the power supply board. This is yeah, this is a real hot zone for faults, and been replacing capacitors. Oh, I'm just replacing all the capacitors because they're all cooked. Yeah, this is quite the board. And you can see the areas that were, who's been doing the cooking is these transistors. I pulled one transistor out and I tested it. Let me show you here. You can see this in the focus is, let's see, glare. And this one just tests like a couple diodes or resistors. And this is one of the pass regulators on the power supply board. So I just pulled it out at random and checked it, and it's not working. Let me try that again. Yeah, it's testing like two diodes, back-to-back diodes. So that's going to get replaced. And that kind of makes me suspect of all the rest of these transistors and stuff, because they're all cooked. This one used to be green, but it's now brown. Yeah, I'll just go through it, make sure everything 100%. I'm surprised this thing even turned on with the way the power supply was buggered up the way it was. But we'll get it going. Okay, so I'm finished working on the power supply board. A lot of things were wrong with this board. A lot of things. We had many cracked solders, especially around these transistors and some of these resistors as well. So I resoldered the whole board. It's all been done. Gave it a full recap because probably 80% of the capacitors I pulled out there were junk. And two dead transistors, past transistors, this one and this one. This one here regulates the minus 54 volt supply to the power amplifier. And this one here, I can't remember what this one regulates. There's also an 8 volt regulator here. I haven't tested that yet, so I'll have to do that once I power it up. Yeah, all recapped, a couple new transistors, added some heat sinks to these transistors over here that were getting baked, and gave them a little bit extra help. So this can all go back in. It's a good thing I went through this and found a lot of these problems. This past transistor here that was dead, luckily it didn't short and pump 70 volts onto that rail. So I'm going to go, as a precaution, I'm just going to go back into the power amplifier and check all of the components that are attached to this line. Let me show you here on this diagram. So that transistor that died was this line here, N. And this comes from the power supply, and this supplies, if I can catch it, 53, I think it's 54 volts, negative 54 volts, and it supplies all these transistors here with a negative potential, all of these. So I'm going to go in and check all of these transistors, make sure there's nothing dead or funny going on. Just want to make sure I do my due diligence before I power it up. So I can put this back in. It's just a matter of rolling it back into place. And I'm kind of running out of things to, let me see if I can get this back in. Just like so. Kind of running out of things to check here because I haven't checked the tuner. And there's a lot of digital stuff going on here in the front with this is the power meter. And what else we got here? We got some switching. And then all this over here is tuner. So looks like we're getting ready to do a first test, power test. Okay, I'm finished checking over this audio amplifier board. I'm not finding any more faults. I did remove the relay to clean it, but I couldn't open the case up. This thing is totally sealed and I didn't want to bust it, and I didn't want to buy a new relay. So what I did is I did something a little different to clean the contacts. What I did is I connected up a load across each contact, like about 2.5, 3 amp load, and then I switched the relay on and off a few hundred times. And what that does is that when the relay is closed and open with that heavy load, that 3 amps or whatever, it cleans off the oxides on the contacts and cleans it off and gets it working again. I had
two sets of contacts here that were, I can't even remember now, was it running around 25 milliohms? And then I had another set of contacts, these two in the back here, they were running around 15 ohms or so. And then after I did the clean with the heavy current, they all dropped down to about 20-25 milliamps, or milliohms, sorry, of contact resistance. So this relay's ready to go. That plus the two sets of contacts are wired in parallel, as you can see here. Now, a few other things I need to do before I reassemble. I got a problem with these transistors. The heatsink compound's all dried up and yeah, it's just needs to be redone. So I'll clean all these transistors off, regoop them with new fresh silicone grease, and then I'm going to get rid of these goofy connectors. These really bother me. I wouldn't trust them to make a reliable connection on these transistors. These transistors are dipped in tin lead solder, so they're not meant to be used as a contact surface. They're meant to be soldered into the circuit. So what I'm going to do is I'm going to cut these connectors off, all 8 of them, and I'm going to replace them with a little terminal block like this. This little terminal block with the screws, and I'm going to just bend up the leads on the transistor, drop this in place, and then you crank them down, right, and tighten them up, and that's a secure connection. I'll just solder the wires to the back 3 pins, and that'll be it. That'll be my solution for this. And yeah, once you tighten these down, there's no doubt that you're going to have a good connection. It's not going to be flaky or intermittent. So I'm going to do that. So I'll get busy on this. I need to remove these transistors and clean them up. All right, the power amplifier is back together. Everything's assembled. This is what it looks like with the connector blocks on each transistor. I did have enough room on the wires. They were long enough, but I'm not happy with the wiring they used. It's a single core solid wire that breaks very easily if you flex it more than 2 times. And I should have replaced all these wires as well, but I was kind of, I don't know, maybe a little lazy. But this will work. This is, I did continuity checks between all the connectors and the transistors, and everything's connected. No broken wires, so that's a good thing. Yeah, everything's done. Recapped. 2 new transistors. 2 caps here, 2 caps here, and 2 caps here. Everything else has been checked over. It's all ready to go back into the unit. So let's see here. I think all I got to do left is install this, and we can start power it up and do a test. Alright, the power amplifier is reinstalled. I've done a lot of other work. Spent about 3-4 hours today cleaning buttons and switches and controls. The tone controls are cleaned. These switches were cleaned. The input function switches were cleaned. These switches were cleaned. And I went through these 2 printed circuit boards, this printed circuit board, and a few others. Power supply has been reworked, completely rebuilt. Word on the power supply, we had that fault on the negative 54 volt supply. That transistor failed, and it didn't short because it didn't damage anything in the input stages of the power amplifier, and it didn't blow a fuse. So I'm kind of confident that no damage was done because of that fault. So I'm going to go with it. I got it plugged in now. Speakers hooked up. Got my watt meter there. So let's try this. Let's turn it on. We still got no click. Let's try it again. Yeah, we have no speaker relay. We're drawing 60 watts too. It's kind of unusually high. Before it was set 45. So I'm wondering where the heat's coming from. Yeah, those got a lot of potential on them. Let me see this. Interesting. So let's measure the outputs of the amplifiers one more time to see if we have any DC offset on this. Alright, so there's definitely something weird going on here. Let's see, what did I do? I did some voltage checks around on the protection circuit. Everything seems normal. And I was checking the collector voltage on Q140, this transistor here in the middle. It's supposed to be, what is it, 0. Well, this is the 140 is the one that turns this relay on and off. Let's see here. Yes. And it says it should be 0.6 of a volt because the emitter is grounded, I believe. When it's turned on, it should be sinking current. So, anyways, I put my voltmeter here and I was testing this, and as soon as I touched that center lead, that collector, the relay clicked on. So what's going on here now? Is there something? They got a broken connection, or? But I'm wiggling the transistor. I don't see anything wrong here. Maybe this transistor's bad. That's what I'm thinking. It might be a bad transistor. So I might have to pull that transistor out and replace it, which is no big deal. Just a matter of disconnecting these wires here. 3 connectors on the bottom. The whole module comes out. Alright, moving along here. Let's do the setup for the amplifier. This is unconventional from what I'm used to, and I really don't understand. It doesn't describe what to do exactly. It just tells you the values and doesn't tell you the procedure. But it does tell you this. Okay, turn VR3, VR5, VR4, VR6 fully around in the counterclockwise direction, but set VR1 and VR2 in the center positions. Okay, so we got 6 pots here, 3 for each channel. There's 2 white ones and there's a blue one. The blue one is your DC balance, so we're going to set this to the center position here, somewhere there. And let's set this one center position somewhere there, and then we're going to crank these down, crank all these down. Okay. So that's what it wants us to do. So, what do we do now? See, without any load or input signal, turn the power switch on. And that's all it really tells you. So, we have 2 points here where we can take measurements. There's 2 jumpers here and 2 jumpers here. You can see that in the camera, can't you? Yes. Okay. So we're going to connect our voltmeter to these 2. Actually, first what we're going to do is we're going to do the DC balance. We're going to have, we're going to set for 0 volts on the output. And what I'm going to do is I'm going to set my voltmeter on the center conductor of these emitter resistors, and that's the speaker. That's the speaker output. So let me get set up here. Alright, so I'm set up on the center conductor of the emitter resistor. That's the speaker output. I suppose I could also tag onto this resistor here too, but this will work. Let's zoom in on the voltmeter, and this here is your wattmeter, voltage in watts. This top right is the watts, so keep an eye on that. So let's turn this on, and then let's set the DC. Wow, it's really out. Turn this down to 0 volts. Plus minus 30 millivolts. Just about there. Okay, Right there, I'm going to leave it. So let's power off, and we'll do the hookup for the other channel. Okay, we're on the other channel now. Turn it on. You can do this without blocking the camera. Two millivolts, that's pretty good. All right, next we're going to do these adjustments here. Now this is what is confusing. I don't understand what's going on here. I think they want us to adjust these in order. Like you got VR3 first, and then you adjust VR5. So you connect up your probes to jumper 13 and 15, which I can do now. Jumper 13 is this one. And jumper 15 is the other. Okay. So what they want me to do first is adjust VR3. VR3 is, let's see here, this one here, the inside one, the inside white one is VR3. So let's turn on power. And we are at 50 millivolts now, so let's turn this up to 56. It's jumping all over. Why is it jumping all over? That's not cool. Got dirty pots. You can watch the power draw go up as I turn up the. Okay, so we're at 57 now. 56. Turn it down a little bit. Now, from what it says here, I turn pot VR5 up to 70 millivolts, and that's using the same jumpers. VR5 is the one that's on the outside here, so let's adjust this one up to 70 millivolts. See that power consumption keeps going up. This is a thirsty amplifier. It's drawing 60 watts at idle. Well, it's about 50 watts. There's about 10 watts for all the other. So we're at 70 millivolts now. We'll leave it there. Okay, so left channel is adjusted. So let's move probes over and do the right channel. All right, we're wired in for the right channel. So let's turn this on. And let's turn this up to 56 millivolts. A little too far. Okay. Next step is this one goes up to 70 millivolts. All right, so we're set. Look at the consumption here, 76 watts at idle, 77 watts. It's not a very energy efficient amplifier. That's it, we're done. Alright, now that we got a working power amplifier and working power supply, we can go back and do our initial check to see what else
is working here. I don't even know if the tuners are working yet, so let's power this thing on. And we got a relay click, so that's good. Speakers. Speaker 1. Auxiliary. And there's our test tone, but it's very, very quiet. And I think I know the reason why is because I removed the jumpers from the preamplifier and power amplifier. So let me put those back in right now. Shut this off. I always forget about these jumpers. So what do we do here? We gotta put this one here. Okay, let's try that again. Okay. Got a lot of buzz. Maybe distortion too. Okay, that distortion is the ground I'm missing here. Let's try FM. Hang on, I need the controls to see what buttons I'm pushing. All right. So this should be down. We have an automatic. Okay. Scans, picks up stereo.
Amazing. It really.
Everything's working good with the FM. Full bars. Full bars, stereo signal. Quartz locked. It's stuck on this.
Donc elle répertorie. Puis aussi elle est.
Okay, it goes down to the bottom and then bounces back up. Let's go up. Let's try AM. I'm getting nothing on AM. Picking up signals, it's just not breaking through the threshold of the muting. Let's see here. These are switches. Let's try that. It's unusual to go by 1 kilohertz steps. Never seen that before. Okay, here we go. Let's see if we can pick up a 880.
Days National second of 4 days of Jubilee celebrations in London and all around the United Kingdom. Meanwhile, more somber.
Yeah, AM's working good. It's got full bars.
This weekend marks 100 days since Russia invaded.
Okay. Tone control. These are supposed to light up, but they're not. This incandescent bulb in there burned out. Yeah. Okay, so we got to change these 2 bulbs. We'll do that. Oh, these bulbs are working, eh? No, and no. Okay.
So when I push it in, it's moving coil. When I push it out, it's moving magnet. So the moving coil lights are working. The moving magnet ones are not. So I'll have to change those two bulbs. And these two bulbs. A little bit of scratchiness on the pot. I cleaned these potentiometers already, so they're working. I believe they are. I don't hear any difference in the... And I did clean some switches too. Okay, there, it's working now. You can hear it. The switch is still dirty. Good, good, good. Good. Oh, there we go. It's a dirty switch. Okay. Alright, so I got a few lights to change, and that seems to be about it. And a pot to clean. Everything else is good. Yeah, that's good. Good news. Okay, so we're just about done this. Alright. So here's the function selector board and phono preamp. On the right hand side we got the phono preamp, and this switch here in the middle is the moving coil moving magnet switch. This one sets up the amplifier for different gain, and you know, these 5 switches here, these are my function AM FM phono 1 2, and all these bulbs are working. Just stand by. Yeah, sorry for the interruption there, but yeah, all these bulbs are working. So the problem lays in either these switches, 2 switches here, or this switch here. And I tested this switch, these 2 switches, they're working. But so this leaves this one here, and it comes down to it. It has to come out because it needs a cleaning, and there's no way to spray anything in here without getting it everywhere. So I'm just going to remove the switch. I think it's just easier that way. So I'm going to use some solder wick and let me get this thing out. Let's see what we can do here. Maybe go out of frame. Usually I'm pretty good at getting you guys out of frame, but not today, huh? Smoke. So yeah, you don't need to watch me do this. I'll do this and then pull the switch out and have a look. Okay, so I removed the switch. Let's get into it and see what we can do. This is kind of a unique switch where you can put the contacts of the switch down on the PCB board where they need to be, right next to the circuitry, right in the middle of the circuitry, and then you can actually attach this to the front panel, and you can do it, you know, anywhere you want, and the two work together. It's there's a ribbon of, looks like stainless steel in there, and when you, latching mechanism on the end here, and when you push it, it moves the switch in and out, or left to right, whatever way, and then you have all your contacts. But for whatever reason this is not working, or it's not providing continuity to those lights. So how do we, I've never actually opened one of these before, so this is going to be interesting for me too. I think these are modular, like a lot of these switches, these Alps switches, I think this is Alps brand, yeah, it says Alps on here. These are modular. They have the same mount on a lot of these switches, and these same mounts have been used for a lot of years, and you can actually bend these tangs up and put different switches in this mount, And it looks like it's a modular thing where you can just order up a latching mechanism, order up a motion transfer cable or whatever they call this thing, and then order up your switch in the configuration you want, and then you just put the parts together and away you go. But I don't know. Let's see if this pops off. I don't know if it does or not. It looks like it will. Now before I remove this, one thing I need to do is mark the orientation of the switch so I don't. So let's put a little arrow on this side. Otherwise, if I put it together backwards, it might not work the same. So yeah, this just pops off. And you can see the mechanism, how it works. And then it fits into one of these slots. Interesting. Okay, but that doesn't get us any closer to the contact. So let's open up, let's bend these tangs, and we'll take the bottom off. So I want to do this carefully. We don't want to break anything, because the switch, even though it's part of a modular system, is probably unobtainable at this point in time. I want to be very careful with any switch, any vintage switch you take apart. You just don't know if you can ever find a replacement again, so, or a new old stock or anything like that. So you just don't want to break anything. You don't want to be paying the prices for the part scalpers on eBay when they take a receiver like this and butcher it and sell the parts individually and for profit. You don't want to be paying their prices. Okay, so let's see how this fits together. Just put it in the center, I guess. And I should mark the bottom as well with an arrow so they all line up back together again. Let's pry this open. It should come out. Something to pull on it with. Very light pulls. Don't want to break anything. Still got one holding here. Another thing they like to do is when they manufacture the printed circuit board, they put the switch on the board with the pins in the hole, and then they bend over the pins to hold the switch in position for the wave soldering. And if you straighten those pins out a little too aggressively, they'll bust off. Then you got a real problem on your hands. So I'll just gingerly open this up. I hope it all stays together. Or is it going to fling across the room? This is really tough. Tough cookie. It's getting hung up on these. There we go. And there's our switch. Okay, so let's also mark this as well. So my arrow's pointing this, point this arrow this way. And you can see it's kind of unique in design. Okay, I see what's going on here. There's 4 pins for each switch. 2 pins, or the outside 2 pins, are your common. And then you have a choice between this side or this side, A or B. And we have 6 switches like that. They're all identical. So all this needs is a good cleaning. Let's give it a good cleaning. We'll put it back together, and then we'll... Anytime you take one of these switches apart, have a good look at how it's constructed. Like, for example, these copper beryllium contacts. These 4 on the outside are all identical. They look identical to me. And then these 2 in the middle are different. These ones, they go deeper, make contact down here at the base, and these ones make contact way up here on the top of the contact here. But yeah, they're not the same. So if you take one of these apart and the pieces fall apart, you have to remember how to put it back together. Because if you can't put it back together, you can't get the switch to work again. So let's do some cleaning here. You can see how badly it's oxidized. And that is not good. Let's can I clean that with? Let me try something here. I'm just going to go with some of this stuff. And we're going to give it a shot of this. This isn't very good stuff though. I'm not totally pleased with it. Let's see how it removes this oxidation. And see, it's not coming off. Okay, let's move on to something else here. This stuff here, Neutral Control Cleaner. This has a lubricant in it. So let's try this. It's very volatile, like it'll evaporate quick, but then it leaves behind that oily residue. I don't think this one's cleaning it very good either. Okay, let's try just some plain old deoxit D100. I'm sure anything that we put on here will be better than what it was before. Oops. Okay, so let's continue with this. You can see the silver is really oxidized on these. It's the silver plating. Careful. It is coming clean. Let me try this again. You have to do both sides. Notice how it's oxidized heavily on the outside here, and then the inside is relatively clean. That's because the oxygen is penetrating through the cracks here. If they made a sealed switch, it would work a lot better. Maybe not, who knows. You can't really get aggressive with sandpapers and stuff on this because the problem with sandpaper is that you'll remove the plating. Yeah, let's try some. Okay, I'm going to do something out of the ordinary here. I'm going to get a scrubbing pad and I'm going to cut off a little chunk. And we're going to use that to scour the surface. We're not going to go through the plating though. I'm going to just do a very light scrubbing with this. Actually, you know what? I think I could probably put some contact cleaner on here as well. Okay. And we'll just clean up this. Clean up this oxidation. I think that's going to be good enough. You see the silver starting to pop. Okay, and do down inside. So mainly on the end, the switch is on the outside. Let's get a little bit more on this. Still, on the inside, there's really a lot of oxidation. Right at the ends. Okay, that's all I dared to do. Throw that away. Give it a clean. Okay. Clean this off, and then we'll reassemble. Let me have a look at these contacts. Yeah, they're okay. I thought I saw some green corrosion. I think it goes this way. All right, now you can just line these up. Which way is my arrow? That way. Arrow this way. Some fuzz. Give it a little treatment before we close it up. Okay. Ah. See the wide part of the body here. This wide part of the body has to go in the middle slot, and then there's a little, the narrow part of the body here has to go into one of these side slots, and they have to be lined up all together, yeah, so they're all in unison. Otherwise, if you have one that's out of position, then it prevents this cap from dropping on. So let's try this again. There we go. So I think I have a choice. Yes, that's working. And oops. There we go. Make sure they're all lined up and they're all correctly situated, because if you have one that's out, then the switch won't work properly. Give them back and forth to let the deoxit do its stuff. Okay, let's carefully pull this off and see how they're lined up. As good as it's going to get, I guess. Okay. Oh, what can we do with this? Nothing. Generally, I don't lube the switch itself. Just let it go dry, but I'm just going to give it a little touch of lubrication here. And then reorientate this. It shouldn't really matter though. Okay. Let's crimp these. Carefully crimp these back down. You don't have to go crazy on them, just fold them half, you know, at a 45 or so, and then the bottom will stay tightly secured. Okay. We're good. Let's put it all back together. So, let's switch position here. This is, okay, we need this out here. Snap, snap, all done. Okay, I'll solder this back in. Should be working now. Okay, now that I got the switches installed, I got the switch installed and everything back together again. Just want to give it a test. Got FM, AM, auxiliary, phone 02, phone 01. We go moving magnet, it turns to green. If I move it to moving coil, or that's actually moving coil and moving magnet. So that's working now, everything's good. Perfect. Now I need to deal with these bulbs. I do not have these installed. These are really tiny. These are 8 volt 50 milliamps, and they have to fit into the hole here on the back of this little adapter thing. Just like so. And I don't have bulbs this tiny. I do try to stock all kinds of different bulbs. 8 volt at 50 milliamps is, at this size, is really kind of odd. So what I'm probably going to do is end up doing a retrofit, an LED retrofit on this. Get some amber LEDs, and I think that's the color of choice for this is amber, and install it here. Now I think this is 8 volts. Let me shut this off. I think this is 8 volts regulated DC. So let me cut this bulb off, and then we'll strip it, and then we'll do a measurement of what we have here. Okay. Actually, let me get a different meter. Let me connect up. Alright, so let's turn this on AC. Turn this on. Is it AC? No, it's not. Or hang on. DC, 8.5 volts. Exactly. Okay, so what I'll do is I'll do an LED retrofit on these two bulbs for the tone controls, and that'll be the end of that one. These won't ever burn out again. Yeah, it's kind of a weird setup. This bulb here is burned out as well. They glue them in too. And I pulled the glass apart. That's how bad it was. Alright, so this is what I devised for the tone control illumination. Each slider on the tone control pots has a little light, and this is a bright orange LED, 3mm, and you can't see it here, but it's in behind this sleeve is a 1.5K resistor, and I just finished soldering this up, so I was going to heat shrink this. Let's do that now. I can't heat shrink with 450 degrees. Let me turn it down. Okay, so let's heat shrink this. And you can see it in action here. I'll just turn it on. You can see it's quite bright. And this will fit into the adapter. And we get light. Alright, so we have to anchor this somehow. Let's do this. Okay. So to anchor it, I'm just going to use hot snot. I'll just let that cool. Doesn't look pretty, but it's going to work good. Okay, got the lighting finished. 2 LEDs added for the tone controls. Repaired the switch. The moving coil, moving magnet switch was not engaging the lamps for the different modes. So let's try it. We've got phono. If we go to moving magnet, moving coil. I hope I don't get that backwards. So that all works. We got our tone control lights working here. You can see they get a little knob that has a little cut in them that shows the light shows through. Now, all that's left to do is I need to service this tone board here with the volume pot, or it's actually a volume attenuator, because it is a special attenuator potentiometer. I'm just not sure if I can get this out without disassembling the entire thing, because I have this tuner board in the way, and I need to get it down and out to get it past the front panel. I might have to remove all the screws from the front panel and move the front panel forward maybe an inch or so and see if there's enough slack to do that. But let me remove these screws. This is the last little bit of work I need to do to this thing to finish it off, and then we can move on to something else that's broken. It's kind of an honor to work on these things. I got clients that bring me these monster receivers like this, for example. See, here it is. It's not going to go as back. The power supply board's in the way. Yeah, so like I was saying, it's kind of an honor working on these monster receivers. I get my clients bring them to me, I service them, and then they go back, and I don't have to keep it either. That's another thing. It just takes up space. But yeah, I enjoy working on this gear, and I appreciate my clients for bringing it to me. It's awesome. If I took the power supply out again, I don't think I would have room. I'm going to need at least 1.5 inches here. One of the secrets, I don't want to take the tuner board out. Yeah, I should have thought of this before I put the power supply back together. I can take the screws out of the power supply and lift it up. It would move it that way, and it would be out of my way, but it would gain me about 3/4 of an inch, but it's still not enough. I think I have to remove these 3 screws, and probably let's see here. No, that should be it. And if there's enough slack in the wiring harnesses, I can pull the whole thing forward and get this board out so I can service it. Let me think about that for a while. Yes, okay, so there's 3 screws on the left side, 3 screws on the right side. I loosen the top screws off, and then I remove these 2 and these 2, and the front panel is now able to rock out far enough that I can get this out, and I can service the attenuator, which is great. But I'm also looking at this board here, and it is just loaded with very low value electrolytics, like 0.15 microfarad. Why wouldn't they just use film caps in here? Like, this is silly. What is this one? 0.68 microfarad. I'm going to replace all these with film, and there's a couple other electrolytics here. I'll replace all of these so that I won't ever have to touch this board again. Okay, here's the volume attenuator. This is an Alps unit, probably a custom-made job exclusively for Pioneer, and it has 2 100K pots and 2 10K pots, but it shows 5 here. So this one here on the very front, that is this potentiometer for the balance control. It's coaxial, and then we have the shaft that runs through to these rear 4 potentiometers, and this is our volume attenuator. Yeah, good luck on finding a replacement for this. This is probably a special custom made up thing that Alps made for Pioneer, but it does have screws in the back, so we can remove those screws and see how far we get in. One thing I did notice is that the coaxial here is really sticky with grease, and when you turned up the volume pot, you could see the balance control moving. It was getting dragged, so I just wanted to address that. And then this balance pot is really sticky, so I'm just going to add a little bit of oil, just the smallest amount. I don't want to get too carried away, because if you get too carried away with the oil, it changes the viscosity. And so I added a little bit between the two shafts, and then I added a little bit around the collar here, and this should free it up a little. When you turn the volume up or down, you don't want to be dragging the balance pot as well, because then you have to readjust your balance every time you adjust your volume. Okay, I'm just going to leave it at that. It's got a nice feel to it. And I'm get carried away with oiling the shaft. So let's pull off the back and see what we got. There's 2 screws. And not much going on here. We have shows that we can see the last potentiometer in the gang. That's about it. All the other ones, we have this shaft with this well, it's a lock nut and a press-on lock nut, and you would need to cut this off. You would need to cut off this nut and have replacements on hand, and I don't have replacements on hand, I don't think. Or actually, you know what? I think I might. Let me check. See, I bought this kit on AliExpress, but it only goes to the smallest sizes of M3. Let's see here. I need a pair of tweezers. We're limited in sizes. We got M8, M10, M6, 12, M5, 4, and 3. 3 is the smallest. And I'm assuming this is an M3 here. Maybe not. Let's see. Yeah, they're all mixed up. I think that's the M3. So let me see if this is even the right size. Just put it on reverse and see if it pushes on, and it does. So it's not the right size. It's too big. I would need a M. What is this? It's disintegrating. Insulator. So, if you absolutely had to remove this end to repair something within this pot, I won't do it today because there's no need for me to get in there to do it. I can spray stuff in through these holes. But if you had to get in, you got a number of choices. You can find the replacement nut. I don't have. And you could cut this old nut off, take it apart in sequence. You've got to remember what sequence it's in so you can put it back together correctly, and then you can put it all back together. Or another option would be just to cut this end off. This is just aluminum shaft. This here's the aluminum shaft. You could cut that end off, remove the nut, remove the pieces, do your repair. Then to put it back together, you'd have to drill a hole, a small tiny hole, and thread it for a small screw. I don't know, this would probably be too big even. You have to get something smaller, and then a spring washer, and then put your screw back and put it all together and lock it together so it won't come apart. So it is possible to fix these. It's just you know, it's going to take a little bit. So for today, all I'm going to do is I'm going to spray Neutral in here, and we're going to hope for the best. It wasn't really dirty when I tried it out, so let's do the balance pot first and give this a workout. Okay, and let's do the other. It seems like there's some kind of grease here. Let's treat the other ones, the other three. Let's give it a short little blast and we'll treat it. It gets goo everywhere. It seems to be flushing out some kind of a lubricant, which is okay because neutral has its own lubricant. And for the last little bit, we can add a drop of deoxit F100, very small amount. Let's put it back together. We're done. Okay. Don't go crazy on the torque, it just holds it together. Straighten a few of these bent pins. Okay, I'll reinstall that. Alright, so I've been busy doing some cleaning and assembly. But there's still one adjustment we need to do that I haven't done yet, and it is the set up the power meters for accuracy. So what we're going to do there is apply a 1 kilohertz signal to the power amplifier. In this case I'm going to feed it into the auxiliary. Then you turn this up until you have 8.94 volts on the output, and then you adjust the potentiometer here to show 10 watts because that's what we're playing for here. Okay, so let's turn this on. Let's go auxiliary. And I do have, okay, so I have a 1 kilohertz tone being fed in, and everything seems to be working. Got both our channels, left and right. Okay, tones defeated. Everything else is good. Okay, so I'll turn this up until we get 8.94 volts RMS. And you know what? Got the stepped attenuator, you can't what I'm going to do is do it here. I'm going to adjust it here on my signal generator, that way I can get a good result here. Hang on. Okay, 8.94 and we have 10 showing up, so let's adjust this. Doing the right channel, which is the bottom one. Oh, that's a bit dirty. Okay, you adjust it so it just turns on. Right there. Okay, let's do the left channel. Change my voltmeter around. And I have an 8 ohm load on this, by the way. Let's do the top one. to our right channel. Things are drifting here. Here's my not the right screwdriver. Let's try this one. I think as the amp warms up, it is putting out a different level. It keeps climbing. Turn that back down to 8.94. Let's turn this up. Okay, now it looks like we need to go back and do our right channel again. Right channel is a little bit quieter. It's quite a bit quieter actually. It's reading 8.46 and my left is reading 8.95. So there's a bit of difference between the two. Try this. Well, those meters are accurate now. Okay. So one thing I'm going to do is I'm going to check the bias one more time and make sure it hasn't drifted, because working in here you can bump this with your hand and knock one of these pots out of alignment. So I'm going to check it one more time, make sure it's good, because right now I'm consuming 90 watts and I got everything shut off here. There's no power coming out and it's quite warm. It's a power thirsty amplifier, that's for sure. So I just want to make sure I didn't bump a bias setting, and then we'll get on with the power test. Alright, we are set up to do a power test. I got my voltmeter on the left channel. And let's turn this thing on. See how it does. Okay, bringing it up. Already into clipping. Holy. Okay, let's let me see here. I need to adjust my scale on my scope. Yeah, let's try that one more time. Bringing it up. Let's see here. We have clipping. Right at this point, which is 34.76 volts RMS. We're consuming 463 watts from the outlet, so that's Not as efficient as I'd like it to be. Let this go for a while. Let it warm up. Okay. Let's do some square wave tests. Alright, feeding it a 500 Hertz square wave. Let's turn it up. I'm not going to go full power here. I'm only going to do maybe 10 or 20 watts. Because we can do full power, but we're not going to. Only about 15.6 volts RMS. Okay, let's increase frequency. Looks pretty good. Tone controls. Oh, it's got something scratchy in the left channel. And I've cleaned all these switches. Tone controls off. Have no effect. Okay, let's go up in frequency. Okay, we are at 4.5 kilohertz. You can see the rise time and the fall time is not the greatest. And I think that's because the tandem outputs have a lot of capacitance on the junction, and that's the reason why. So as we keep going up higher in frequency, we'll just get less and less of a square wave. Where are we here? We're at about 10 kilohertz. We're over 10 kilohertz. And turn it down a bit. Yeah, the rise and fall time is really killing this amplifier. Okay. Let's do a little bit of frequency response. Let's see here. Let's get I'm gonna do a frequency response. Let's see how low we can go. Okay, so that's 2 hertz, 3. It's pretty flat on the bottom end, really flat. I was quite surprised by that. Okay. Do the high end. Let's go up. Frequency 1 kilohertz. I'm only pushing about 7 or 8 watts right now. Okay, so we're at 4 kilohertz. Let's go up. What happened there? 17, 18, 19 kilohertz, 20, 21. Seems like we're getting some harmonics. 34. Well, we're up above 50 kilohertz and it hasn't dropped off yet, so it's doing pretty good. This amplifier is pretty impressive, except for the slow rise times. Alright, so here's a look at the parts that went into this thing, or parts that came out of it, because these are the parts I took out. So there's 50 capacitors, electrolytics, these big ones in the back here, these are all out of the power supply. Majority of these are out of the tone board. These are audio grade, very early version of audio grade. But for example, this is a 0.68 microfarad. So I replaced these with film caps, and they'll be stable for the rest of the life of this thing. These transistors, these are blown transistors. Actually, not blown. This one's not blown. These ones are blown, and these diodes. This is out of the power amplifier, and this is out of the protection circuit. And this is another transistor I took out of the protection circuit just because it had low gain. And when I was troubleshooting it just didn't have good gain, so I took it out and replaced it. These two transistors were blown in the power supply circuit, believe it or not. And this one here, the green one, was for the negative 54 volt supply. And that regulated 57 volt supply supplied the early stages of the power amplifier for clean power, and it wasn't working. So a lot of stuff went into this to bring it back to life and get it sounding good again. Yeah, but this is when you get a monster receiver like this, you're gonna have to expect a lot of parts to be of this vintage to be done and finished. But yeah, we got it sounding good now. So let's have a little listen. Okay, so I've done this. My last thoughts. I got a lot of mixed feelings about this amplifier, or this receiver. It's a monster receiver. It's one of Pioneer's great flagship receivers. They put a lot of technology into this thing. They even went to the effort of the pilot lights, for example, on these. On any typical receiver, they just have an 8-volt tap off the power transformer, and then they run wiring for the lamps. But these guys, what they did is they took that 8 volts, they rectified it, filtered it, and they regulated it to 8.6 volts, and then they fed it to the bulbs so that there's a pure DC on all these bulbs, and it was super quiet. There's no hum. And I think they went to those extra efforts to build a receiver that was a step above the rest, and it's got a lot of nice features that you will not find anywhere else. And it's an awesome rig. My cons for this is power consumption is one thing, has me concerned. 75 watts sitting at idle. It's a big monster amplifier, but it's thirsty, and it's going to suck a lot of power. The other one that concerns me is the square wave. It's usually when you start getting transistors, big power transistors, and you tandem them up, and you spread them out over heat sinks, and you got long wiring, you're going to lose that fast transient response with the way the power amplifier is laid out. And they could have went to a different design power amplifier layout, and it could have improved a lot of things. But I think overall, it does the business, and it has the beans, and it's a good amplifier in this thing. So I'm going to give this about a week trial on my desk, because I have the owner wants to pick it up and get his hands on it. So I'll have to quickly test it out, and if there's anything that crops up, I'll have to put it back on the bench and repair it before he picks it up. So, but otherwise, it's all ready to go, and it's done. Alright, so it's probably a week later after I finished the video off on this receiver, and I've been listening to it. I gotta say, it sounds really good. It's got a really punchy bottom end, but then, you know, any amplifier that has tandem outputs, you're going to have really low impedance output on your amplifier, and you're going to have a high dampening factor, and it makes a difference in the sound when it comes to your bass. If you have a big amplifier with tandem outputs, you probably know what I'm talking about. But this thing does have a problem, and I am not happy with it idling at almost 92 watts. This thing gets quite hot, really hot. So what I'm going to do is I'm going to go in and redo the bias adjustments, because when I did it originally, I did it when the amplifier was cold. And when you first turn it on, it registers about 65 watts, which is more acceptable. But then as it warms up, it climbs to over 90 watts, and it heats up and heats up. So I'm going to go back in now. It's fully warmed up. It's been listening to it for about an hour now, and I'm going to redo those bias adjustments. So you can see as it warmed up, the current through the emitter resistor has gone up from 70 when I originally set it to, is now up at 85. There's no description of how to do this properly. It doesn't tell you to warm the amplifier up. It doesn't tell you to do it warm. It just tells you to do this adjustment here. And if you do it cold, it's going to creep up on you. So 56 millivolts and 70 millivolts. I'm going to actually opt to go lower. I'm going to go a little bit lower, just in the interest of keeping this thing cool. So I'm going to leave it around 52, 53, and then this one I'm going to adjust to about 65, and we're going to leave it at that. Okay, and our current consumption's dropped from 91 to 96, so we lost 5 watts there. Okay, let's do the other channel. Okay, we're up over 100 millivolts. Turn these down. Maybe this is why the reason it's getting so hot. Okay, our power consumption dropped to like 60 watts. So let's bump this one up to about 52. Let's see if I can do something with these pots, because they're really jumping around all over the place. Alright, so what I did is I pulled those 4 bias pots and cleaned them up. They were a little scratchy and a little flaky, so I cleaned them up. Now they're solid. When I adjust them, they don't jump around. So I reset this to the bias to 65 millivolts for both channels. And power consumption right now is at 80.5 watts. See that? The problem is it's climbing up again. So I set this to 65, now it's up to 71. So I'm going to wait till this gets up to operating temperature, and then I'm going to redo the bias one more time, which is probably going to be lowering it. I would be a lot happier if this dissipated 75 watts and not 90. Curious to see how much. Well, I could do the calculations with the voltage measurements across the emitter resistors. You can calculate how much current's going through those transistors and how much heat is being wasted from just idling. And I think I measured and calculated it's in the order of 35 watts. It should be 35 watts when it's all properly adjusted, but when it was up, this was up over 100 millivolts, so it was probably more like 60 watts was being let go here. So I'm just going to let this go and warm up, and I can see it's already up to 73, 74, and it keeps climbing. So I'll just give it about half an hour and we'll readjust. Okay, so it's been running about half an hour here, stable at the same current. It hasn't been going up, hasn't been going down. Got it adjusted, both channels adjusted around 63, 64 millivolts. And my consumption on the power meter is down to around 74 watts. And I'm a lot more comfortable with that as opposed to having it up around 91 watts. So it's going to run a little cooler now. it won't be so quite so hot to the touch when you put your hand on it. I can actually keep my hand on it now. So I think I'm going to leave it like that. I feel better about this now that I turned it down, because it was cooking too much. And anytime you get heat in an amplifier, that's a bad thing. Try and keep your heat down to a minimum. All right, so I'm going to close this one up. And yeah, thanks for watching again. Talk to you later. See you on the next one.